Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyxel Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home. Hi, and welcome back to another podcast. And in today's podcast, we're going to cover Wi-Fi 7 or 802.11be. And we have a special guest today, Hugh Simpson. Welcome to the show.
No, thank you for having me. It's great to be here.
So maybe we should talk a little bit about the history and talk around how we evolved to where we are today. Do you want to maybe explain a little bit about that?
Yeah, so it's interesting. We've now moved into the lettering or the numbers, etc., away from the lettering and the standard name. So, Wi-Fi 5 was 802.11ac, Wi-Fi 6 was AX, and now we're in Wi-Fi 7, which is the BE standard. So again, it's an ever progressing line, and again, there is news out there of Wi-Fi 8 coming along. Late 28, for instance. So it's not going to stop here.
It's evolving. It's evolving.
Never stops, right?
It never stops.
Okay, so should we maybe talk around the frequency and the technology? Because I think there's a big misconception about Wi-Fi 7, and it gets tangled up with the frequency quite often about the 2.4 gigahertz, the 5 gigahertz, the 6 gigahertz, especially the 6 gigahertz versus previous versions. Whilst there's a lot of technology in Wi-Fi 7, right?
Yeah, it's an interesting one. Wi-Fi 2.4 gigahertz and the frequency 5 gigahertz, and now with 6, they are distinct. They have their own advantages and disadvantages, etc. We all know that 2.4 gigahertz is utilized by everything, Bluetooth, microwaves, you name it, it's on the 2.4 gigahertz range, right? 5 gigahertz came along and that was slightly cleaner. Unfortunately, there are radar and other technologies based in that frequency. And then now we've got 6 gigahertz. But let's be careful when we talk about 6 gigahertz and the fact that we've only got a certain range, approximately half of it in Europe. Whereas if you read a lot of the press and a lot of the information that comes from the US, they've got the 1,200 megahertz of bandwidth. So again, we've got to be really careful. And again, what is in the frequencies and what is in the technology. So we first got used to the 6 gigahertz when we moved into Wi-Fi 6E. And then ultimately now we've moved into Wi-Fi 7, which is an improvement on Wi-Fi 6 in that range.
But you mentioned that in the US, they can take the full spectrum. But how much can we use in Europe?
So we've got approximately 500 megahertz in Europe, which, yeah, it's not the full 1200, and we could complain and we could moan about it. But actually, let's consider what 500 is. That is more than what we get, or approximately about the same as we get in both the 2.4 and the 5 gigahertz added together. So we've pretty much doubled what we've got out there right today.
So there's a lot more capacity than we've ever had before.
Yeah,
right?
big increase.
So when we take it over all these bands, really, it's a big improvement.
Yeah, it really allows us to utilize, and we'll come on to it a bit later on, the 160 megahertz channel widths, etc. We'll come on to that a bit later.
There's some pretty high specs, right, from Wi-Fi 7, or hopes and dreams from a lot of people, right?
Yeah, one of the headlines is that Wi-Fi 7 has the potential to do 46 gigabits of data, theoretically, with the 16 by 16 stream. That is a very dedicated piece of hardware, right? We'll be lucky in the market to see 8x8 access points coming out. Certainly, Zyxel, we have the 4x4 and now the 2x2 access points in that frequency.
Well, obviously we'll go on to some of our APs a little bit later. I think, we want to explore the technology a bit more. The 2x2, the 4x4, the partial streams, it's quite a lot of detailed information. I think we could even break out into another podcast, I think, to discuss this, right? It's quite a lot of information.
Yeah, especially when we talk about antennas and those kind of things.
Yeah. Let's talk about some of the advantages that the technology part of Wi-Fi 7.
Yeah, that's that's great. One of the big things that we can all utilize is the modulation, right? So again, if we look at Wi-Fi 5, that was 256 modulation, QAM modulation. That went to Wi-Fi 6, went up to 1024, and now we're at 4096. So, we have increased our modulation, and that basically allows us to squeeze more data into the same bandwidth.
But Hugh, maybe for our audience, maybe you should explain WAM, what it does in your Wi-Fi.
Let's try and keep it down though, right? As in, let's make it into something that people can relate to, right?
Because if you're an engineer, you probably say, "Oh, okay, I understand." Yeah. But we want to make sure that everyone can.
We often
learn from this.
Yeah, we often use the scenarios, right, where there's the lanes of a motorway or the vehicles, etc., right? But from my point of view, I can do this bit if you want, right? Because we can talk about a truck in the back of a truck, and we had so much stuff in it, but now we're getting double, then 4 times as much eventually, right? So
in the same lorry.
And it basically let's cut out all of the lanes and the cars and everything, jargon, etc. It gives us 20% more throughput potentially.
What would be the speeds that you think we should really expect to see? Obviously we've got this 46 gigabits per second, right? But the reality is that's not what we're going to see, right? But what do you think customers will really experience in Wi-Fi?
Whenever we talk of Wi-Fi and the speeds and the theoretical speeds of connection and throughput, it comes down to what the client is as well. So, you might have the best access point and the 8x8 access point or the 16x16, but if the client isn't going to connect or being able to deliver that, it won't be able to utilize those spatial streams and channels. So again, we have to look at both sides. But realistically, let's throw some figures out there, see a connection of about 6 to 8 gigabits, and the throughput of that though, that's the connection. The throughput will be potentially half of that. So we should get some real world speeds of 4 gigabits.
So some real wire speed breaking. And we'll cover some of that a bit further. I think it's really important to talk about that bit as well.
Yeah, but I think that people should know to achieve those speeds, the number of antennas. Yeah, sorry to talk about antennas, but it's really important, because if you just are receiving on one antenna, you'll never get that high speed.
Yeah.
So your client needs to be adapted to your very fast access point that you're using.
Yeah, those speeds, they also rely on using really wide channel widths as well, right? So in Wi-Fi 7, they have the 320 megahertz channel width. Is that a reality to use that? I don't think so, right?
No, it's not. No, we, unfortunately within like I said, that's the downside to the amount of frequency that we get in Europe. We only get 360 megahertz channels within the 6 gig space. That realistically allows 320 megahertz channels. So, we're not going to see that throughput, and we're not going to see those top speeds, etc. But we can't put the downside on that. We will, like I said, we've got 360 megahertz channels, which we've never had before, or never clearly had before. So that is a real blessing in that space. And we can utilize that with the QAM levels, etc. So we can achieve more speed and greater speed than we have done with Wi-Fi 6, for instance.
But it's important, I think, when you talk about the channel widths, it's really important to, consider what's best for your scenario. We did Michelle and I did a podcast actually on deploying in a warehouse, and we talked about, considering the best channel width for your type of environment. In a warehouse, you could even go down to 20 megahertz wide, right? So it's all about making the best of your scenario.
Absolutely. Channel width is a big discussion point, and it actually comes down to interference and how many access points you're deploying, how much Wi-Fi is around you, what other devices are utilizing those channels, and actually whether you need it, right? Because if your client isn't able to deliver that speed or doesn't need that speed, then why are you congesting those channels? You don't need to, right? So again, but it gives you that complete flexibility. So Wi-Fi 7, although you might not utilize it all, gives you the flexibility and allows you to, as the clients improve and as the technology improves, etc., allows you to utilize that.
I mean, I know when we saw Wi-Fi 6E come, we started extending into the 6 gigahertz, but actually the technology wasn't there like it is in Wi-Fi 7, right?
Yeah, I was wondering, are there any applications already that are really looking for this kind of demand of speed on the Wi-Fi?
That's a really great question there, Michelle. It comes down to the fact of what needs that bandwidth, right? And those high speeds. And more importantly, what the latency is. Those channels and that speed gives, and Wi-Fi 7 really drops the latency down. If you're a gamer, for instance, if you're using VR headsets, etc., broadcasting, the latency is all important. And that really, Wi-Fi 7 really helps with that.
But I could imagine that maybe Kev contributed this as well, that maybe in a video environment with a TV studio, I know you have some examples in that one.
Yeah,
that can be a big help that you have such a bandwidth.
I mean, there's some other elements as well, like the density as well, right? Because we also improve the amount of devices we can connect. Obviously, that helps us, deliver.
Yeah.
By the mass as well, right? Lots more devices simultaneously.
Yeah, has an influence on the performance. Yeah.
And obviously, we've done some work with some video studios, where they're producing adverts and video production and film production. And Wi-Fi 7 in this scenario has absolutely made a big difference to them, right? And they're trying to really push the boundaries in delivering over Wi-Fi, and we'll talk about multi-gig and some of the connectivity stuff as well, right? But this has allowed them to surpass the speed that they would do on a 1 gig wire, for example. So yeah, absolutely. I think there are still lots of scenarios that will take advantage of Wi-Fi 7 at the beginning. I would say as devices progress and start to leverage from it, the density will be able to improve by the amount of devices. And you should consider about older generation devices, and this is a completely different topic as well. So, we could go into that and it could really expand it, right?
Yeah, but let's look at this. Is the first time that we've released a standard with Wi-Fi 7 that the clients have been there and thereabouts. I was lucky to get hold of on launch day, Google 8 Pixel, etc., and that has Wi-Fi 7 built into it. Again, I had to wait for the latest operating system, etc., and everything else. But, normally there's been a delay between the client and the access point and the technology. This time, no, absolutely. It's really there. And the clients will be coming out thick and fast. And, they will be utilizing these higher speeds and require these higher speeds, etc. So again, it's not just the clients, it's the applications, etc.
But question, Hugh, the high speed, are we achieving this just by using a single frequency? Is it only the 6 gigahertz that provide us the high speed, or
no? We've got that's also great. Another advantage of Wi-Fi 7 is that we have multi-link operation, MLO, and this allows the clients that are able to utilize all 3 frequencies at the same time. So therefore, whereas Wi-Fi 6 or 6E, you can only connect to one frequency at one time, MLO actually allows your client or your device, if it's capable, to connect to all 3 frequencies at the same time. And therefore we can get, higher throughputs, etc. Because, you can look at it as a single frequency, but again, we can utilize all of them.
So it's really taking advantage of all 3 at the same time, right? What the best of all three?
Yeah,
all 3
absolutely.
bands.
But you really need all 3, or you can leverage from only 2 if those are available.
At the end of the day, it depends on what's available.
To the device.
Like I opened up, 2.4 is really congested, has a lot of noise in it, etc. You're gonna have a lot of co-channel interference. Is it really the best channel or the best frequency that we should be using? And therefore, we want ideally to remove out of that channel. But lots of devices still use it. It's still there.
It gives you a little bit of redundancy as well.
Of course, it does.
Yeah.
So there's lots of advantages to MLO, right? I think it's one of the major technology enhancements in the Wi-Fi 7 for sure. And I think when that comes into play, it will really allow us to deliver the services much more reliably over all the advantage of all the channels at the same time. So I think that's a fantastic part of it. Another technology that's in there though is puncturing. And I think, but yeah, exactly, yeah.
Is this a disease or what is this?
when we used to have co-channel interference, or we had interference arrive, or we had another signal cut into our Wi-Fi signal, that would be end of it. It wouldn't work. You might still be able to connect, but no throughput. Your data is destroyed, etc., because there's this other interference that's come in. What we can now do is, when that interference comes in, it punctures our channel, okay? And you could use an example of a road, for instance, a motorway. We've got multiple lanes. There's a pothole or a crashed car in one, or a blockage in one of those lanes. Whereas in the old world, we'd have to close the whole motorway down and remove that interference, or actually change frequency or channel, etc., to bypass that.
And slow down your data rate, of course.
Of course, yeah. And absolutely destroys it, right? What puncturing allows is actually we only close down that single lane, that single channel, and we can work both sides of it. So even if it punctures in the middle of it, we can work both sides of that interference. It doesn't just close the inside lane, etc. Actually, we're allowed to work both sides of it, which is really great.
Wow, that's quite impressive, right?
Quite smart as well, yeah.
Yeah, absolutely.
So I think with all of this technology and all of the speeds, etc., and we mentioned at the beginning, there's some big changes need to happen in the rest of the infrastructure, right? So switching wise, really need to consider, like, that becomes the bottleneck, right?
Well, this is great. You know, we've been living on 1 gig Ethernet for a long, long time now. You know, I have to say, I remember the days of 10 meg and 1 meg token rings, etc. We've now progressed, and we've been stuck at 1 gig for a long time, and that's met our needs. But now we're progressing beyond that, and actually multi-gig and 10 gig becomes more important than ever.
We covered multi-gig in another podcast, which it was, I think it's June 23 episode, and we covered it in a lot more depth. So, of course, in this one, we're not going to cover every single thing, but if you're interested in more information about multi-gig, then we cover it in that, and it's worth a listen as well. But certainly, when we're talking about the backbone from an access point into the network, there's some considerations.
Absolutely. The major considerations when you move into the multi-gig environment and when you're dealing with these high-end access points, is first of all, PoE. You know, have we got the right power budgets? Have we got the right standards? You know, there are multiple different standards that are out there, you know, ranging from, and we've again moved away from the numbers into plus symbols, etc. So
PoE plus, and plus, or ultra PoE, whatever. Yeah.
There's quite a few, right?
Yeah.
802.1180. Yeah. BT.
Even more.
You could make a song out of it, right?
Yeah. So again, power considerations is really important. That's a plus. The other thing is when you move into 10 gig and the high-end Ethernet, you know, you've really got to make sure your infrastructure, your physical cabling is suitable for it. Otherwise, it's just not going to work, and you're going to spend a lot of money on the infrastructure and the access points and the switching. But if your actual core cabling isn't right, then it's all going to fall down.
PoE wise, I mean, obviously the bigger access points, the more antennas and the more arrays that are in them, and even some of our technology where we include smart antenna, and again, we can cover more. That's a big topic in itself, right? But when we talk about that, the requirements are much higher as well, right? So they draw over the PoE plus standard, right?
Yeah, so we have PoE plus, which is the BT standard again. Yeah, and that allows the access point, the WBE 660S, to work with all its antennas, right? You know, if we don't achieve that PoE plus standard, the BT standard, and we only can supply 80, the PoE plus standard, then the antennas drop down to 2 by 2 by 2.
Yeah, and then it reduces speed, of course.
Yeah,
of course.
So again, you know, we have another podcast. We like to refer to them for today. We did one on PoE and about consumption mode and all these different elements.
Fantastic.
Yeah. So if you're interested in the PoE part as well, we did one in September 23 as well. So that's worth a listen to understand the PoE standards, etc. And it's not really the right place to talk in detail about it here anyway. So let's talk about some of our APs.
Yeah, let's start
Wi-Fi
with
7.
Yeah, let's start with our flagship product. Yeah, what is it called? 660S.
WBE 660S. Yeah, I've kind of talked about it already. That is our flagship. That's the 4x4x4 triple radio, so it works across all 3 frequencies, access point, and that's a fantastic product, right?
And the theoretical speed of this unit?
Theoretical is approximately around the 8 gigabits of throughput again. It depends whether you are single frequency or multi-link frequencies, whether your client can support your all of the antennas and all of the frequencies, etc. So again, the throughput will be above the single gig speeds, etc. You'll be able to see 3 to 4 gig of absolute throughput.
It has 10 gig on the back, right?
Yeah, sure.
Yeah, but it's going to need 10 gig, right?
Yeah.
So it's theoretical, as in headline speed is 22 gigabits per second.
Yeah, on the Wi-Fi, yeah.
But I mean, obviously, when we deliver it into the network, we have this 10 gig. That's fantastic, right? That's the real headliner. But what about for those average people, right? Who don't need 22 gigabits per second?
We've got the new NWA 130 BE product coming. That will be available beginning of March. So that's a fantastic product. That's an 11K theoretical speed we're going to see these speeds above 2.5 gig, around that kind of point of connection.
And this model has got 2.5 gigs on it, right? So one upstream and one back out again.
Yeah, and the other important thing is it's just 2x2x2. So again, it hasn't got as many antennas on it, etc. But it will still give you a great experience within Wi-Fi 7.
Wow, so that's quite a lot of information on Wi-Fi 7. I think that we've covered quite a bit today, right? So.
Yeah, you can say that. And also, we refer to other technology as well, like multi-gig, power over Ethernet, smart antenna.
We're just dropping those in there, right? But I mean, thank you very much for joining us, Hugh, today. And I think we'll wrap up there, right? And,
Thank you for having me.
No problem.
Yeah, thank you.